All right, guys. So yesterday we talked about our first special right triangle, the 45, 45, 90, and we based it off of a triangle. Well, today we're going to talk about the 30, 60, 90 triangle. We're going to start this with an equilateral triangle, and the first thing we're going to do, number one, is we're going to draw the height. Now, what this is going to do, and we also can call this the altitude. I don't know if you've heard that before, but when I draw in the height, it forms two right triangles, okay? Since it's equilateral, it cuts the bottom in half. So what I'm going to do is I'm going to say that this we're going to call x, and this is what we're going to call x because it cuts it in half. Now, I know in an equilateral, I have 60-degree angles, but when I draw that altitude at the top here, it splits it in half and makes these both 30-degree angles. And since we drew a height, it makes it a 30, 60, 90. Now, if the bases are x, then that makes the hypotenuse, which is twice that far long, 2x, which means we need to find out what the height is. So what we can do that, and number two, I'm just going to say is label short leg x. Sorry, I probably should have put that a second ago. And then number three, we're going to find the other sides. So the 2x was easy because if we cut the base in half and it's the same length and we double it and get 2x. But that height is kind of tough. So I'm going to set up a Pythagorean theorem problem here. I know that a squared plus b squared should equal c squared. Well, I know two of them. I know the short leg is x, so I'm going to say x squared, plus, and then we always have a short leg and a long leg, so I'm going to call this the long leg instead of assigning it a variable, and then I'm going to square that. But I also know that the hypotenuse is 2x, so I'm going to square that. What that ends up giving me is x squared plus, I'm going to put long leg squared, equals, now when you square 2x, it's 2x times 2x, which is actually 4x squared. Now I can subtract the x squared off the left side and put it on the right side. So I have the long leg squared equals 3x squared. Now I can take the square root of both sides, and I get that the long leg equals, we can take the square root of x squared, and it's x, but that 3 is stuck inside. So our long leg is x square roots of 3. Now, if you're not sure how I got that, that's not that big of a deal. What's important is that you know what the actual assignments are on each side. So down here, we're going to label them. Now, we can turn this and make it look different, so we always have to remember this. Across from the 90-degree angle is our hypotenuse. That's always 2x. Same thing on the other one. Across from the 90 is our hypotenuse. Then the short side, the side across from 30, is always going to be our x side. So the side across from 30 is going to be x. And then our last one is across from the 60. That's where we get our x square roots of 3. On this one, we'd have our x square roots of 3. So keeping that oriented is a little tougher than the 45, 45, 90. So across from 90 is the 2x, across from 30 is the x, across from 60 is the x square roots of 3. So let's look at this problem down here. Same thing as yesterday. They're going to give us a side. We need to decide what goes with that. So 14 is our hypotenuse, so that is our 2x. Across from our 60 is our x square roots of 3. And then across from our 30, which they didn't tell us but we can find, is our x. So this one's pretty easy. I know that 2x equals 14, so I can solve for x by dividing by 2. And I get x equals 7. And since they gave us that side, it's basically just a plug-in problem. LM, x square roots of 3, I plug in the 7 for x, and I get 7 square roots of 3. And then MN is just x, which we found to actually just be 7. So not too bad there, guys, but it gets a little more complicated when we go to our next. So I'm going to go ahead and label every side because this can be tough. I'm going to go ahead and say, okay, here's my 2x. Across from here is our x square roots of 3. And then the short side, this is my x. So they actually told us what x was. So I can find both the other sides pretty easy. I can take 2 and multiply it by our x value, 2 square roots of 5. And when you do this, guys, the 2 only multiplies to this piece. Remember, 2 squared 5 is just a number. So I actually get 4 square roots of 5. So ln, this side over here, is 4 square roots of 5. Now the other one's a little bit trickier. I can fill in the 2 square roots of 5 for x, but then I have to multiply it by the square root of 3. So be really careful when you do this. We can multiply the numbers. Lost my colors there. But really, there's just a 1 times the 2, so I get 2. But when I multiply the radicals, I multiply what's inside, and I get 15. Now, 15 cannot be simplified, so I just have 2 square roots of 15. Now, that can be pretty tough, so if you have any questions about that, just let me know tomorrow. Now, this one, we kind of looked at some that worked like this yesterday with the 45. I know this is 2x. I know my short leg is x. This time, they gave me the x square roots of 3 side. So if I'm going to finish this, I have to solve that for x. So I'm going to write it over here. X square roots of 3 equals 8. Now to solve for that, I'm going to divide both sides by the square root of 3. So I know that x is 8 divided by the square root of 3, but that's not going to work because I have the radical in the denominator. So let's use our clever form of 1. Yesterday, we used the square root of 2 over the square root of 2 because that was the denominator. Today, we're going to use the square root of 3 over the square root of 3. But the same process works. 8 times the square root of 3 is just 8 square roots of 3. The square root of 3 times the square root of 3 makes the square roots go away and leaves us with 3. So now I know that x, this one down here, is 8 square roots of 3 over 3. Now remember, I try to simplify if I can, but you're only looking at these two numbers. The radical is stuck there, and 8 over 3 does not simplify. Now I need to find 2x. So that's 2 times 8 square roots of 3 over 3. Now really that's 2 over 1. And remember, you multiply numerator by numerator, denominator by denominator. So 2 times 8 is 16, and the square root of 3 stays the same over 1 times 3, which is 3. So our 2x side, or ln, is 16 square roots of 3 over 3. And then I guess I didn't fill in the bottom one. That was what? 8 square roots of 3 over 3? Sorry. So that can be kind of tough. We can talk about that in class. Sometimes just doing a few will help you out. Let's look at this last one. Now, you might try this one on your own real quick and see how it works. You know, because if you can do this one, you probably are pretty good. But they gave us the 2x side this time. Across from 60 is our x square roots of 3, which leaves the other side, our short leg, to be x. So I know that 2x equals 4 square roots of 3. So I can divide both sides by 2, and I get x equals 4 square roots of 3 over 2. But I can simplify because 4 divided by 2 is 2, so it's actually 2 square roots of 3. So I'm going to come down here and write my x. I guess that's mn is 2 square roots of 3. Now I need to find my x value, or I'm sorry, my x square roots of 3 value. Now really looking at this, now when you look at this one, what I know is what x is. So 2 square roots of 3. I need to multiply that by the square root of 3. So just like the last one, I really have a 1 out here, so 2 times 1 gives me 2. But the square root of 3 times the square root of 3 is 3. So I can multiply 2 times 3 together to get 6. Now this can be really tough, guys, so we will kind of go over it in class tomorrow a little bit at the beginning. But if you have any specific questions on the homework, make sure you make note of them and ask me tomorrow. Good luck, guys.